What is that? Hello, everybody. I am just panning around, giving you a bit of a background of where I live. The neighbors are getting some work done. If you can see, scaffolding going up and some beautiful flowers. We got some bushes. Look at that. Awesome. I don't know too much about plants. I do know that I have a very nice backyard. It's nice and green. And just looking back, there he is. That's Harry. And then here's another one. Ratcliffe. That's my other pug. They are really fun to have. Thank you for joining in. So far, the name of this channel. I think the name of this channel, other than my name, which is just ridiculous, might be something like Probability Dude. Dude, what's a probability? But that doesn't really sound like it works. It's so hard to think about that. Like, what's the name gonna be? After maybe 100 vlogs, we'll check it out. There's one channel that I like to watch, and I don't see it all the time, but it's called Chateau Diaries, and it's a really good, great channel. There's actually a lot of channels that have sort of like grown out of it. And it's about a woman, Stephanie Jarvis, in France, and she has a chateau, and you hear her story, and she's got a lot of vlogs and a bunch of stuff. But it's just called Chateau Diaries. It's perfect. But then there's a few other things that have sort of emerged from the channel because of the way she's done it. I just don't know what mine's going to be yet. That's okay. It'll happen. Something will emerge, and I'm very aware that I'm showing bins in the back, and that's never that's never good. What is the likelihood that I would have bins back here? This is good. This is my nice little green backdrop and the line for the house. Here is apple tree in a pot. We'll see how that goes though. Okay, so what do I want to talk about today? Yesterday I outlined the 3 basic axioms of a probability, but that got me thinking about the notion of events, of beliefs, of how much we can know about a given situation. And I thought, in relation to mathematics, one of the things that's fundamental is the idea of a set. So what is a set? So you could naively say a set is a collection of objects, but then what's a collection? Collections of collections. And what is an object itself? What constitutes an object? So, if you're looking for like fundamental definitions and you want to really split hairs or split the cells on the hairs, you can definitely go in. But if you just think, let's say a set, and this is a lot of math, and so a lot of math, you come up with agreed upon definitions, and then you build off of those based off of some logic and some intuition. And when you're in school and you're learning mathematics, you're learning something like, if anybody took algebra, then they'd be familiar with the quadratic equation. And there's so many people that they had to learn that, and they had to learn it rotely, so they just have it memorized, that it's x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And it's not a super complicated equation, but it definitely, I think I was in grade 8 when I learned it, and you get a lot of people that are nervous by that sort of level of things. Something like the square root sign, which is like, it looks like the divisor between the numerator and the denominator, and then there's a little like line thing, and I think that could freak people out. and the fact that it's a rational expression, meaning that it's a ratio. I hope this wind is not too much. Oh well, we'll see what it is. That when you start getting into the syntax of mathematics, it gets to be, I think, a burden for people. And the syntax is helpful. The nomenclature is helpful, and the jargon is helpful. If you want to talk about a certain object in mathematics, I keep pausing it because it's windy, but that's okay. If you want to talk about a certain object in math, then you tend to need to talk about something that everybody's agreed upon. So, for example, in an area called abstract algebra, you have structures called groups, and then there's a whole area called group theory, and that's just basically a type of thing that has a list of rules and conditions on that thing. And as long as you match that, then you got that thing. But not everybody can say, oh, that thing that we're doing, it's got those 7 things. Oh, I thought we were doing the thing that had 6 things. Oh, you guys are doing things, I thought we were doing boxes. So you need to have a level of agreement. And how do you get a level of agreement? Well, then you start having all right, hello, welcome back. It's technically going to be like halfway in the middle of the video when I say this, because this is the second day that I filmed. Yesterday I was filming my normal, hey, what's up, let's talk about math or life or anything, and my space in my phone went out. So I had to do a bit of research on, not research, but like a bit of investigating in my phone on where all my data was going. Turns out most of it was going to like downloaded movies or PDFs. I download so many PDFs. It'll be like, hey, I'm interested in nonlinear dynamics. Let's go find a PDF on that. Or game theory, or a book actually that I want to get is The Statistical Consequences of Fat Tails by Nassim Nicholas Taleb. He wrote The Black Swan, Fooled by Randomness, and he's got some YouTube videos on it, and I really like his work. So I found the PDF, I downloaded it, so I easily have hundreds, if not thousands, of PDFs of books that I am one day maybe going to read. Or if I had them in real life, I would just have them on my bookshelf, and then people could look at it. And then, if I had somebody over, oh yeah, what's this? Oh no, it's nothing. Don't worry about it. It's just easy reading, easy reading. Even though I've never read it. One of my little ego things, I guess. I definitely like to seem smart, but that's okay. I like to be who I am. I'm not saying that I'm smart. It's not even something that I think about all the time is whether or not I'm smart. It's just I like to do things, and I'm gonna do them. For example, I've really been into this Wim Hof breathing. I know I've mentioned this a few times, and I love it. It's like I've done a lot of yoga, and I used to be in karate. I did it for 5 years. I've done kickboxing, the cardio, light type of impact. And the thing that you see everywhere, and you kind of hear it all the time, breathe deeply. And I was always two minds of it. One of me was like, great, let's do some deep breathing, let's breathe, whatever. And the other part of me is like, yeah, I didn't really notice the difference that much. And I feel like a lot of people might be the same way, or they might be like, oh, I don't really want to meditate, I'm not into that type of thing, which is fine. But what I noticed with the Wim Hof breathing, it's almost activity itself, because have you ever just tried to breathe? Just breathe, but focus on the breathing in the sense where you're breathing like this, right? So I'll just do a few. That's 4 breaths. Now imagine doing that 30 times, 40 times, 3 minutes, 4 minutes. A few things you're going to notice. First off, the motion of air coming into your throat actually makes it quite dry, so you start feeling like you need to cough. But you'll get used to that. You kind of keep doing it, stop, cough, whatever. But you'll actually get used to it. And then once you get to 30, so you're on your last breath, you're like, and then you just breathe to a specific neutral position. So I'm breathing, as you can tell, I'm actually holding my breath in at the same time as I'm talking. And you just hold that. And then you get to whatever time you can do. And then you do another breath. So as soon as you've breathed out, once you've held your breath for however much time you can do, you hold it again. Do it for like 15 seconds. And then do that 3-4 times. And Jesus, like, it's so good. I can feel like my body shifting. Sometimes I'll feel tingling, I'll feel warm, and then also I'll feel an amazing amount of relaxation. And you could just YouTube Wim Hof, and he's a cool guy. He's Dutch, and he's got a cool story, but I'll let him tell it. You can go find it. But doing that breathing every morning, it feels so good. Sometimes I'll do it before I go to bed, and sometimes I've never slept better. Because some of the things that are happening, like you're actually releasing endorphins in your body. So by you doing this breathing, you are actually learning to control parts of your autonomic nervous system, and you're able to really like work with your body and feel relaxed. I love it. It's absolutely phenomenal, and it's changed my life. So for your, I don't know, 8 payments of $9.99, I always do that. I've noticed. Okay, so ages ago when I lived in Australia, I started doing Shaun T's Insanity, and I did that for a year. Like, I did the Insanity program, which is like 60 days, and then I did it again, and then I went and did Insanity Asylum. I did T25, and I freaking love those. Like, they're brutal. Like, I don't know how many times I hurt my knee or my calf or my heel, or just I was in constant pain for a year. And but it was really good. Like, I noticed I was so much more hungry because I wasn't eating enough, and that's actually a story for another time. But I did it for a year, and then one of my mates, he hadn't seen me in like the start to the stop, and he says, "Oh, dude, John, you've lost like 10 kilos." I was like, cool. I didn't notice that, but I did notice I was able to do the workout more easily, not up to scratch with everybody else. Anyways, I found that when I was telling people about Insanity, that, you know what, they should have just started filming me and putting me on one of the infomercials, because I was sounding, I'm telling the story about, oh yeah, it's great. I don't need a gym. I do the workouts. I feel really good. I'm in my body. It's just awesome. And as I'm saying this to people, I so many times, it's like, Jesus, John, you sound like you're in an infomercial. And now I know why everybody thinks Americans are salespeople, because I couldn't help it. It was like the way that I was excited about this thing and the way that I spoke about it was what the people that were on the commercials doing. I don't know if that says something about my susceptibility to media or what I should be doing. Maybe I should just get into a product and I'm just like, okay, everybody, this week talking about blenders, and everybody knows I have always been about blenders. Doesn't matter, blenders. And then like 2 weeks later, I'll be like, okay, everybody, I want to talk about something really important, pots. I don't know how many times you guys have known that I've been about pot plants, and I'll just go off on that, and just this endless brain of some idea, and it's always the idea that's like, oh, this is it. Shit, guys, quiet. Shh. This is it. This is the thing. And then give me like, I don't know, 3 days. I'm actually doing it, and I'm like, oh, this is so boring. What's the next thing that's going to be it? The thing that I'm going to be like, holy shit, this is the thing I've been waiting for. I think that's why I have so many textbooks. So I think, when you have all of that, if you find, and maybe people are like me where they have that same thing, but if you find that there's one thing that maintains itself, or Or another example is like, take a break. Let's say you take a break from work. And in the case of me, it's like take a break from work, take a break from my PhD, take a break from anything else that I'm trying to do. And then it's like, what do? Once you've relaxed, once you've chilled, oh, there's a plane going by. That's what it sounds like to me. I'm just giving you guys the experience of being here with me. Yeah, I don't know. Once you take a break, you stop doing the grind, because the grind keeps you. It's designed to keep your attention on it and to not think for yourself, not have a second to be like, well, okay, is this who I am? Is this what I want to do? So if you do that, if you get to that point, you stop doing those things, you're like, okay, what do I want to do? What is my inclination? And maybe that means you've got to stop and just honor something about yourself. Maybe you're lazy, but maybe it's a good thing. Maybe you need to be lazy, because maybe once you've been lazy for a while, some sort of creativity like strikes. For me, I have noticed that I just want to go and read math and think about certain aspects of mathematics. And it's not that I'm obsessed with math, even though I am. It's more that I'm thinking about like the infinite. I'm entering into a meditative space in which I'm letting something wash over me. And a good example of this is the idea of numbers. And if you pick up a rock, you have this idea. It's like, okay, I've got no rocks. So let's say you have a bag that you keep all your stuff, and you've got no rocks in there. And this is a world where rocks matter. We've just made up the world where rocks are currency. And so you need rocks. Maybe you can't find rocks, so you've got to do shit for, you got to do stuff for rocks. And then you get one rock and two rocks, but you can never break a rock apart. And let's say bigger rocks don't equal other smaller rocks. Just one rock, one number. Okay, so let's say there's no numbers that you can think of. So you have this world where it's only rocks. That's all. That's the way that you count. But you can't count. There's no 1, 2, 3, 4. You're not even using the concepts of this. But what you can do is you can create this one-to-one correspondence. So let's say you were like a shepherd. Okay, so here's the world. There's rocks and there's sheep, and you're a shepherd. And let's say you're on a hilly zone with trees, and you've got a little, farm with the sheep, but it's a safe area, so you let the sheep go out. So they leave the farm, the little pen. I have this problem with I's and E's and O's and U's and L's. So they leave the enclosure, and every time a sheep leaves the enclosure, you take one of your rocks out of your pouch, okay, and you put the rock on a stump, because stumps are safe. Everybody knows that. Everybody knows that stumps are safe. Rocks are money, and everybody farms, and everybody has sheep, and everybody lives in hills. So every time a sheep leaves the enclosure, you take a rock out, and then you keep doing that. And let's say you have the same quantity of rocks as you do sheep. So you have an empty pouch, and you got all your rocks on the stump. And let's say it's impossible that any of the rocks fall off the stump. Nighttime comes back, and you're like, all right, let's count the sheep. But remember, there's no numbers. So what do? You take a rock, and every time a sheep comes back into the pen, to the enclosement, you put a rock in your pouch. What you should have is all the sheeps in the enclosement and no rocks on the stump. Now that's an example of like counting numbers. You can count them, and finite. So you can count how many you have, and there's an end point. Let's say n sheep. You didn't need to count them. What you had was you had a one rock per sheep. So that's a one-to-one correspondence. So you've now found a way to say, I'm mapping my sheep to the rocks. Obviously, in the world that we live, we have different types of numbers. So I've talked about rational numbers. So the numbers that you have natural numbers, which generally, and this little bit is up to debate. You could say 0 is a natural number, or you could say it's not. I'm going to say it's not. So I'm going to say that 1 on until infinity are the natural numbers. The integers, That includes 1 to infinity, but it also includes negative 1 to infinity, and it also includes 0. So if you have the natural numbers and you have addition as something that you do to them, you can only get bigger. And let's say that you don't have negative numbers, so you can't subtract, so you can only get bigger with the natural numbers. You can say, okay, let's define an operation, that's subtraction, that does that. But when you have integers and you could go negative, you could say 4 plus negative 3, which is just equivalent to saying 4 minus 3, which is 1. So you can go back and forth on the line now with the integers, and you have 0. So you could say 4 plus negative 4 equals 0. That's a special property that you have. Or you could say 4 plus 0 equals 4. So those are some sort of properties in number theory. Now, let's say we've got natural numbers, we have integers, and then let's say we now have the rational numbers. The rational numbers, that's the definition of 4 divided by 5, 7 divided by 20, 458,932 divided by something bigger than that. And you can get extraordinarily large numbers. You could get 999, forever, over a million, and that's like 99% effectively. So those are your rational numbers. And the definition for a rational number is it is a ratio of 2 integers, where the bottom integer cannot be 0. One of them can be negative, both can be negative, whatever. And there's a whole bunch of things that you could do. And there's all these words. Everything that you do has a jargon. And one of the and it's like, if you're on the outside of it, it's like, whoa, that's really smart, dude. But if you just let it sit with you, and then you're able to hold it long enough, you could get past the jargon and you could realize it for what it is, because you want to enter mathematics from the idea of space, from the idea of thinking about stuff in a way that's ethereal. And you could obviously do a whole math degree and never do that, so I'm not saying that's required. That's what I like to do. So you have your rationals. They say your rationals are dense on the number line, meaning that that you can always find any size interval that you select. You can always find a rational number. However, the number line that is solely made of rational numbers is not continuous, meaning that you could never, in truth, draw a line that was infinitely continuous. That requires the rational numbers in conjunction with the irrational numbers. And the irrational numbers, I'll leave it here for there, got its, one of its famous things is Pythagorean theorem, right? So a squared plus b squared equals c squared is your standard Pythagorean theorem. And Pythagorean triples are awesome because it's 3 integers that satisfy that equation. 3 squared plus 4 squared is 9 plus 16 is 25. Square root that, which will give you the c, which is 5. So 3, 4, 5. Any multiple of 3, 4, and 5 will give you the same thing. 1, 12, and 13 is another good one. 6, 8, 10, that's the 3, 4, 5. 1, 1. Oh, what is that? Okay, so you've got all these Pythagorean triples where you integers, and that's beautiful. You think about, I could get a rope and I could notch out 3 notches, 4 notches, and 5 notches, and boom, I've made a right triangle, which is awesome in building, because when you need to, say, lay your foundation and you want to make sure that, assuming your building requires squareness, you want to make sure that your building is square, you can use that 3, 4, 5 concept. So if you take one corner and you go out some multiple of 3, and then you take that same corner, not another corner, that same corner, go out any multiple of 4, then that diagonal should be the same multiple of 5, and then you keep adjusting it until it is, and that gives you a perfect right triangle. So that's awesome. But in math, we like things that are what we call like unity, or a unit. So what's this result? 1 squared plus 1 squared equals 2 squared. Okay, that's beautiful. So the length of that diagonal, well, the Pythagoreans, they, according to lore, they were a religious cult, and they did not believe that irrational numbers should exist. So I think when, it goes that when somebody was like, square root of 2 is not rational, he was killed. As goes the case with anything in a religious sect if it goes beyond the dogma. But that's, the unit square, the length of diagonal is not rational. And so, that starts getting to this idea, well, what is an irrational number? And then for that matter, what's the number system called the real numbers? What does that even mean? And it's understanding that foundation of the real numbers that allows for the existence of calculus, full stop. If you do not have continuity, if you do not have a number system which for every gap that you get, you basically have the same size as the whole universe of that number system, it's not continuous. So if you said negative infinity to infinity of real numbers, that's infinite, that's huge. But that is the same size as 0 to 1, because they say that the real number line is uncountably infinite, meaning that you cannot select a single number out there. You cannot grab one single digit that is a real number, because even if it's an integer, if you're saying it's a class of the real numbers, then that's 1.000, and you'll never stop with the zeros, even though it'll go on forever. And so continuity is massive. It's the reason that you have calculus, and calculus fuels absolutely everything that we do in the natural world. Anything that has a time reference, it is a calculus-based object. And then, of course, you can abstract it, you can discretize it and make it different. But the continuity is so important. And so then when we think about, we've talked about some probability things, and we've talked about, the probability of rolling any number on a dice. So that, 6. And if you say we assume it's fair, which means that it's equally likely that any number will arise, then the probability of picking a 1 through 6 is just 1 on 6. So then you could say, what would I expect to roll? How much, and you said, let's say I got money for any of the numbers on the dice, and you can kind of calculate what you'd expect to make in the long run. But that's discrete. That's 1, 2, 3, 4, 5, 6. What about, let's say, somebody's height? You say, what's the probability that somebody is 5'8"? Well, it's actually 0, because nobody can be truly 5'8" exactly. So maybe you'll look at it with a ruler and you'll eyeball it and be like, oh, it's 5'8". But you've just introduced uncertainty because you've taken a measurement. So you've got a lot of uncertainties there. Did you get the exact height, the exact highest point of the person's head? Are they standing on perfectly flat ground, like infinitely level, and they're standing up perfectly straight? There's nothing on their bodies or deforming them. Then the ruler. Is there anything wrong with the ruler? Was it printed wrong? Was there an error in the width of the lines? And so actually, when you see a line, it says 5'8" or 180 centimeters. I know that's definitely not the same. How thick is that line? Is that line a 1/16 of an inch thick? Is it a millimeter thick? Those things carry with it uncertainty. And when you say, oh, it's 5'8", somebody else say, oh, no, it's 5'8", 5'8.1". Well, now that's a difference. Now there is a difference between those two. So what is the probability that it's one or the other? Well, it's actually 0. You would rather say what's the probability that somebody's between 5'8" and 5'8" plus some small number? Then you're accounting for this little interval. And that's how you have to deal with continuity and probabilities and other things. So I think I just think those things are really interesting, and even if I don't necessarily have some people, they sit with something and they get really profound thoughts. And even if I don't get those profound thoughts, it doesn't really matter to me, because there's an enjoyment factor that I get in sort of meditatively being in that space. So for me, that's when I'm not grinding away, I tend to go to something like that. And so to me, I could sort of trust by that reason that it's really important to me. Regardless of how many times I buy a new math book thinking it's going to be the secret to my my existence. I don't know. Anyways, I think that's what I'm going to stop there. I really enjoyed speaking today. I'm getting more comfortable talking, and I'm really liking that. And at the same time, I just wanted to wish everyone well, peace, love. I should learn it in other languages. Adios, vaya con Dios. I know a bit of Spanish. Auf Wiedersehen. But yeah, leave it there. If you've liked what you've heard, if you felt like I've added value into your life, hit subscribe, hit like, and bells for notification. I am trying to do this every single day. If I'm not able to get one every single day, then I'll do like a short where it's just a few seconds. So I'll leave it there. All right. See you guys. Bye.